Hello all. Previously, we have seen different types of translators that are used in computer programming so that high-level language can be converted to machine-level code. So now let us try to explain the compilation process in C programming language. So what are all different phases of compilation involved in the process of compilation of a C code? Now let's get started. Initially, once you written the C program and save that particular C file with the .c extension, that particular C program can be taken as input to the preprocessor. There is one software program called preprocessor in the compiler. So it will take your C code as an input and do the necessary pre-processing tasks. So what do you mean by preprocessor here? So preprocessor will expand your header files. So in C programs we have the header files, right? Like hash include stdio.h, hash include math.h, or hash define. So don't worry, we have not seen hash define and hash include math.h so far, but we will cover these header files or these symbolic constants or these preprocessor directives in future. Okay, preprocessor will expand the lines of these header files. That is the job of preprocessor, and along with that, it will remove the comments which are present in your .c file. So there are two job responsibilities of preprocessor. It will expand the source code by expanding the header files and then removing the comments. These are the some pre-processing tasks which are performed by pre-processive directive or simply known as preprocessor in the compiler. Once the pre-processing is done, the output of the preprocessor directive is expanded source code, because preprocessor will expand the stdio.h file contents, right? So stdio.h, there are some 900 lines of code. So how printf works, how scanf works, these are the internal details can be defined in a file called stdio.h. Stdio stands for standard input output header file. This is a library file or header file. So preprocessor will expand that lines of code in your C program. So the output is expanded source code. Generally, your file will get enlarged because preprocessor will expand these lines, right? So it will enlarge your code. So what is the extension of expanded source code? hello.i. Okay, every file has some extension. Without an extension, there should not be any file. So your OS will differentiate with respect to the file extensions so that it will segregate what kind of a file it is. So every file has its own extension. So .c is the C programming extension, .java is a Java programming extension, .pdf is a portable document format extension. As you can see, I'm explaining this document in uh, Word document, right? So Word document, we have an extension called .docx. So every file has its own extension. Okay. So what is the extension of expanded source code? It is .i extension. Okay. So this expanded source code can be taken as input to the compiler. So compiler will check for the compilation errors. So inside compiler, there are so many phases like lexical analysis, like semantic analysis, intermediate target code generation. These things, don't worry, these things can be taught in a subject called compiler design for computer science students. Okay, so no need to worry, no need to dig deep what's inside the compiler. So once the expanded source code is error free, that means there are no errors in the expanded source code, the output of the compiler will be the assembly code, that means .s file, that means hello.s. Okay, so .s is the extension for assembly code. So once the assembly code got generated, your assembly code can be taken as an input to the assembler. So assembler will generate that assembly code to object code. That means hello.o or hello.obj. Okay, this is the object code which is near to the machine code, which is somewhat near to machine code, but not exactly the machine code. Okay, so then there comes the linker. Now let us try to understand what is the job role of linker here. So in our project, there might be other C files as well. For every C programming file, compiler will generate .obj files separately. These files should get linked because a project is a one single entity, right? It should be linked. Otherwise, how can you interact with the other components? Okay, that is the meaning of linking here. So hash include stdio.h will be compiled and there will be one object file for that. So there will be one object file for another C file. These files will have different .obj files. So these different obj files should get linked so that your functionality will be integrated. Okay, so this linker will link all the object files which are generated by the compiler should get linked, and then once all the files are linked, then we have the executable code. That is the exact machine code that is called .exe file. This is the exact machine code so that your OS will run this executable file and then produce an output accordingly to your logic. Okay, so once the executable code is ready, loader will load this executable code into the main memory, that is RAM, and show you the output. So OS and loader will combinedly, this loader will invoked by the OS, and subsequently your output will be displayed to the output screen, that is the monitor. So loader is the final step, is the responsible for your execution of C program. So this is the entire compilation process in C language. So what is the job of preprocessor? Preprocessor expand the source code by expanding the contents of stdio.h. By the way, I will show you what stdio.h file looks like. So in which we have a printf and scanf definitions are written. So in devcpp, we are installed devcpp compiler, right? So in C drive, in x86 folder, we have a folder called devcpp. Inside devcpp, there is a folder called mingw64 folder, and inside that there is a mingw32 folder. Inside that we have an include folder where our header files got stored here, where our header files saved here. So inside that just search for stdio.h so that I will show you what stdio.h looks like. So open with devcpp. I will show you how many lines inside stdio.h file. So let us try to go to the end of the line. It is 963 lines of code which are present in stdio.h line, stdio.h. This entire code gets expanded in the process of preprocessor directive. And what is the job of preprocessor directive? What is the another job? It will remove the comments of your program. So it will remove the comments. These are the pre-processing tasks which are done by the preprocessor or preprocessor directive. Okay. So what is the output of the preprocessor directive? It is the expanded source code. What is the extension? hello.i. So, so the hello.i can be taken as a input to the compiler. Compiler will check for the any syntax errors or there any mistakes are there. Once the code is error free, it will generate assembly code, that is .s code, and assembler will take that assembly code and produce the object code which is near to machine code but not the exact machine code. And linker will link all the objects code which are comes from different C files. It will link all the necessary, I mean all the integrated files, I mean all the related files, so that your functionality gets integrated. And then we have the executable code. This executable code will be load to the loader, and loader will invoke, I mean loader will execute your piece of code. So OS and loader will combinedly execute your code so that your output can be seen through your monitor or screen. So this is the exact compilation process which is happening in C programming language. I hope this session is useful. I will see you in my next lecture. Thank you so much for watching.